In this video, I'm going to use an example to demonstrate how some of the decision rules work in decision analysis. So let's look at our example over here. It's coming from two problems at the end of the chapter in a textbook. Place Plus, a real estate firm, is thinking about several development projects. These projects are office park, office building, warehouse, mall, and condos. The financial success of the projects depends on interest rate movement in the next 5 years. The various development projects and their 5-year financial return in $1 million, given that interest rates will decline, remain stable, or increase, are shown in the following payoff table. Payoff table is the building block of decision analysis. In our case, we are going to assume the payoff table and payoff information is given. In our case, there are 5 projects: office park, office building, warehouse, mall, and condos. Those are the things the firm can control. We call their decision alternatives or decisions or options. On the other hand, there are things that are out of the firm's control. In our example, it is interest rate. Interest rate can decline, remain stable, or increase. Based on the information given over here, we would like to answer the following 8 questions. We would like to determine the best investment based on different decision criteria. Those criteria are maximax, maximin, equal likelihood, Hurwitz, minimax regret, EOL, and EV. In the end, we're also going to define a very important concept called EVPI, expected value of perfect information. In question 8, I'm going to show you how to actually calculate EVPI. Next, I'm going to turn to the Excel. The payoff table over here is identical to the ones on PowerPoint slide. Next, let's see how each of those decision rules work. First one, let's look at a Maximax decision rule or decision criterion. In Maximax, this is what we are trying to do. We're trying to find the decision that maximizes the maximum payout of each decision. First, let's find the maximum payout of each decision available to us. First one is office park. Under different state of nature, our profit could be 0.5 million, 1.7 million, or 4.5 million. Obviously, the best we can get is $4.5 million. And this is the maximum payout associated with office park. There's an easier way to do that in Excel. We're going to use Excel function called max. Here we're essentially looking for the maximum value among those 3 numbers. No surprise over there, it's $4.5 million. And we're going to do the same thing for all the other 4 decision alternatives. I'm going to use copy and paste the formula trick in Excel. Here we go. So the maximum payout for office park is $4.5 million. Maximum payout for the other 4 decision alternatives are 2.5, 1.7, 3.6, and $3.2 million. Among those maximum payoffs, we would like to find the decision that maximizes it. Obviously, $4.5 million is the best we can get. Let me highlight it. The decision associated with this value is office park. So based on our decision rule, Maximax, the optimal investment over here is going to be office park. And this is the answer to question 1. Next, let's turn to decision criterion Maximin. This is how Maximin works. First of all, we are going to identify the minimum payout associated with each decision alternative. Here, I'm going to use a function called min in Excel to determine the minimum payoff of each decision. In the case of Office Park, the worst thing that can possibly happen is $0.5 million. Once again, I'm going to do the same thing for all the other 4 decisions. Once we find the minimum payoff of each decision involved, next we are going to maximize it. And we're going to see which decision give us the maximum value among the 5 payoffs we got earlier. It is also pretty obvious. It's $1.5 million. This value is associated with our project office building. So the best investment based on max-min decision rule is going to be office building. In question 3, we're going to look at equal likelihood decision rule. In equal likelihood decision rule, we're going to assume that each of the state of nature is equally likely to happen. In our case, interest rate can go down, remain stable, or go up. And based on equal likelihood, the probability of each of those 3 state of nature is going to be 1/3. Next, we are going to be able to calculate the expected value for equal likelihood method. This is what I'm going to do. For Office Park, there is 1/3 chance of getting a payout of $500,000. There's another 1/3 chance of getting $1.7 million. And there's 1/3 chance of getting $4.5 million. So this is the payout based on equal likelihood. Similarly, we're going to calculate the payout associated with the other 4 decision alternatives. Now let's compare those 5 payoffs. It's pretty interesting over here that we see 2 projects that give us the same amount of payoff, $2.23 million. That turns out to be the highest payout we can get under equal likelihood. The best investments based on equal likelihood has 2 choices in this case. One of them is Office Park. The other is Mall Project. In question 4, we're going to study Hurwitz method. In Hurwitz method, we're going to select a constant alpha. This is how Hurwitz works. The value alpha is essentially the probability we believe the best scenario that is going to happen. So 1 minus 0.3, which is 0.7, is going to be the probability that the worst scenario that is going to happen. Let's look at option 1, Office Park. The best scenario would be interest rate goes up and Office Park give us a profit of $4.5 million. So that is the best case for us. The worst case would be interest rate goes down and the resulting profit will be $500,000. How likely it's going to be? 1 minus alpha, which is 0.7. So let's complete the calculation with Excel. So there's 30% chance we might get the best result we can, which is $4.5 million. And there's 1 minus 0.3 chance we're going to end up with the worst scenario, which is $0.5 million. The resulting value is $1.7 million. And next, I'm going to show you a trick how to use Hurwitz method quickly. Here's what I'm going to do. Okay, there's 30% chance we end up with the best scenario. And what's the best scenario for office building? Essentially, this is what we are trying to do. 0.3 times the maximum value among 1.5, 1.9, and 2.5. On the other hand, there's 70% chance we're going to look at the worst case scenario. And the worst case scenario for office building will be nothing but minimum value among 1.5, 1.9, and 2.5. Here we go. We get $1.8 million. And we can get it done even faster. Why? Because we have the maximum and minimum value for each of the 5 decisions we had. So we can do something like this as well. Okay, 30% chance we end up with the best scenario for warehouse, which is 1.7, plus 1 minus the value of alpha, times the worst case scenario, which is minimum payout for warehouse. So the resulting value is $1.21 million. Let's finish it for the other 2 decisions. Based on Hurwitz method, if alpha is equal to 3, what is the best we can get? It is $1.8 million. The project associated with 1.8 is office building. So office building is the best or optimal investment if we use Hurwitz method when alpha is equal to 3. Next, we're going to discuss minimax regret decision rule. This is probably the most difficult and complicated one among those decision criteria. Before we can do anything, we're going to create something we call regret table, which will be based on payoff table we had at the beginning. And this is how regret table works. First of all, let's identify the best payout for us if interest rate goes down. And it's not that hard to do so. Essentially, it's the maximum value among those 5 payoffs. Similarly, we are going to find the maximum payout under the other 2 states of nature, interest rate being stable or interest rate going up. Okay, now we know that if the interest rate goes down, the best possible thing we can get is $3.2 million. Similarly, if interest rate remains stable, the best we can get is $2.4 million. And if interest rate goes up, the best we can get is $4.5 million. Now let's see what the concept regret means in our case. Now let's look at the first scenario. Suppose we chose Office Park at the beginning, and it turns out that interest rate goes down. So what would be happening? First of all, we got a profit of $500,000. But when interest rate goes down, what's the best possible outcome? It is $3.2 million. So the regret is defined this way. The best possible outcome in that state of nature minus your payout you actually get. So the regret for Office Park when interest rate goes down is $2.7 million. The best possible outcome, 3.2. How much we actually get? 0.5. The difference between the two is the definition of regret. In this case, it's $2.7 million. And we can do the same thing for all the other 4 cases. And let me use absolute cell reference in Excel because we're going to keep referring back to this amount, $3.2 million. Then let me copy paste the formulas. Now we get all the regrets for 5 decisions we have. And no surprise, the last regret over here is 0. Why? Okay, when interest rate goes down, the best possible outcome is $3.2 million. And this amount is associated with our condo project. So if indeed we chose condo project at the beginning and interest rate turns out to be going down, then we have no regret at all. Similarly, we can find regrets under state of nature 2, which is interest rate remaining stable. Once again, here's what we're going to do. The maximum payoff under that state of nature minus what you actually get. So the regret for Office Park is $0.7 million if interest rate remains stable. Then we calculate all the other 4 regrets. And the regret associated with mall is 0. Why? Because if interest rate is stable, the best we can do is to get $2.4 million, which is associated with Project Mall. In the end, let's find the regrets associated with interest rate going up. Now we are ready to apply minimax regret decision rule. To do that, first of all, let's find the maximal regret associated with each decision. First one, for Office Park, the maximal regret would be $2.7 million. And the maximum regrets for office building, warehouse, mall, and condos are $2 million, $3.5 million, $2.5 million, and $3.9 million respectively. Among those 5 maximum regrets, we would like to minimize it. Let's see what's the minimal maximum regrets we have. Obviously, it's $2 million. This makes sense. Why? Because we don't want to have high regrets. The regrets, the smaller the better. 2 is the minimal maximal regrets we had. And this is associated with project office building. So our conclusion is, based on minimax regret decision rule, the best decision or the best investment project is going to be office building. Next, we're going to talk about question 7 before we talk about question 6. Now it's time for us to use probabilities, and this is how we calculate expected value for each of the decisions we have. Right now we expect that there's 50% chance interest rate is going to go down, 40% chance it's going to remain stable, and 10% chance the interest rate is going to go up. Let's calculate the EV for Office Park first. For Office Park, there's 50% chance our profit will be $500,000. There's 40% chance our profit will be $1.7 million. And in the end, there's 10% chance our profit will be $4.5 million. Return, and $1.38 million is the expected value associated with Office Park. And we're going to calculate the EVs for all the other 4 investments as well. Now we get all the 5 EVs. What's the best we can do? It looks like the highest EV we can possibly get is $2.26 million. Once again, let me highlight it. And this amount is associated with condo project. So based on EV, the best investment is going to be condo. ELL works pretty much the same as EV. There's only one difference. In EV, we are using payout numbers. In ELL, we are using regret numbers. And this is what ELL stands for. Expected opportunity loss. And it's nothing but expected regret. So we're going to calculate ELL the same way we calculate EV. The only difference, once again, we're going to use regret numbers instead of payout numbers. Now let's look at ELL associated with Office Park. There's a 50% chance our regret will be $2.7 million. There's 40% chance our regret will be $0.7 million. And in the end, there's 10% chance our regret will be 0. The ELL, or the expected regret associated with Office Park, turns out to be $1.63 million. Then we calculate ELL for the other 4 decisions. Keep in mind, ELL is expected regret. The regret, the smaller the better. So we're going to look for the smallest number among the 5 ELLs. Which one is the smallest? 0.75. Let's highlight it. Based on ELL, the best investment project is still condo project. As a matter of fact, this is not a surprise at all. The project that maximizes our expected value is also the project that minimizes our expected regret. So the optimal decision associated with ELL is also condo project. Now we discussed 7 different decision criteria with which we can find best investment project. It is quite subjective which decision rule you would like to use. But in practice, most of the time, we use probabilities to help us find the best possible decisions. Next, let's answer question 8, EVPI, or expected value of perfect information. Let's say there's a fortune teller who can accurately predict the future interest rate in the next 5 years. But the thing is, this fortune teller wants to be paid. How much is his information worth to us? Once again, we are assuming that this fortune teller is going to be perfect or 100% accurate. We figure that there's 50% chance this fortune teller is going to say, oh, the interest rate is going to go down. There's 40% chance the fortune teller is going to tell us the interest rate is going to remain stable. And in the end, there's 10% chance the fortune teller will tell us the interest rate is going to go up. Once again, fortune teller is going to be 100% accurate or 100% correct. What if he told us, okay, the interest rate is going to go down? What are we going to do? Since the fortune teller is 100% correct, we're going to go with the project that gives us the highest payout when the interest rate declines. That is going to be condo project, which give us a profit of $3.2 million. Similarly, if fortune teller tells us, okay, the interest rate is going to be the same, what are we going to do? Okay, we're going to go with more project, because in that case, that's the best we can do, getting a profit of $2.4 million. Similarly, if the fortune teller says the interest rate is going to go up, the best we could do is to choose Office Park, getting profit of $4.5 million. We can calculate something we call expected value with perfect information. If the fortune teller tells us, okay, the interest rate is going down, how likely would that be? 50% chance. In that case, We're going to go with condo project getting profit of $3.2 million. What if fortune teller tells us, okay, the interest rate is going to be stable? How likely would that be? 40% chance. What are we going to do? We're going to go with mall getting a profit of $2.4 million. In the end, what if fortune teller says, okay, the interest rate is going to go up? Probability of that, 10% chance. What are we going to do? We're going to choose Office Park, which gives us a profit of $4.5 million. We get $3.01 million. This is the expected value with perfect information. Be very, very careful. This is not EVPI, but expected value with perfect information. The thing is, even without the help of fortune teller, we can still get something done. As a matter of fact, without the help of fortune teller, what are we going to do? Oh, we're going to select the condo project getting an expected value of $2.26 million. This is what? This is the expected value without perfect information. The difference of the two is the real contribution of this fortune teller. And this indeed is our EVPI. So our EVPI is equal to expected value with perfect information minus the optimal expected value without perfect information. What do we get? $0.75 million. This number looks familiar to us. This is essentially the best EOL, and this is not a coincidence at all. Indeed, this is the contribution of this fortune teller. He helps us get rid of all the possible regrets, because this fortune teller is 100% accurate. Based on his information, we will never make any mistake. As a result, we will never have any regret. So it's not a surprise that our EVPI is also to the minimum EOL or the optimal EOL.